Pitfalls in sampling. Our learning objective today is students will be able to identify and describe pitfalls in sampling. In the last session, we looked at why we sample in statistics. In most cases, it is simply too difficult to gather data about every individual from a population of interest. A sample of individuals collected from that population will be sufficient to help us make some inference about the population at large. However, there are some pitfalls that we want to avoid to ensure that we can get accurate results from our sampling method. Suppose our statistics class is interested in carrying out a study to determine the average number of Air Jordans a New York City teenager has in their possession. 100 teenagers will be sampled and asked, how many Air Jordans do you have? Consider the following sampling methods. Our statistics class asked 100 teenagers within the vicinity of Bed-Stuy Prep. Do you think this will give an accurate picture of how many Air Jordans NYC teenagers actually have? Why or why not? Pause the video to think through your response. With such a sampling method, we cannot be certain of the truth of our results. This method is called a convenience sample because we're surveying those easiest to contact. This does not mean that the people in our sample are representative of the entire population. Now suppose our class put flyers up around the city asking teenagers to call or text in how many sneakers they have. We've covered the entire city geographically from Staten Island to the Bronx. Is there anything wrong with this study's design? Take a moment to think through your response to this question. Well, who do you think would be most likely to call in? Perhaps those teenagers who love Air Jordans. Maybe these teenagers have multiple pairs. Teenagers who only have one pair or no pairs might feel too apathetic to take the time to call in. The average we get may not be accurate. This is called a voluntary response sample. Both convenience samples and voluntary response samples lead to something called bias. You may be familiar with the word bias in other contexts when you favor or disfavor something unfairly without any reason. In statistics, the meaning of bias is slightly different. Bias is when the design of a study produces results that consistently underestimates or overestimates the true value that we want to know. In the case of the voluntary response sample that we just thought through together, we would likely overestimate the average number of Air Jordans each teenager has because those teenagers most passionate about the sneakers would likely take the time to call in. There are additional sources of bias when sampling. Suppose you've already designed a well-thought-out sampling method, there are still things that can go wrong. So for example, one thing is undercoverage. Let's say certain members of the population could not be surveyed. So let's say we randomly selected 100 cell phone numbers of teenagers, but not all teenagers have cell phones, so all those teenagers without cell phones would be excluded from the sample. This is undercoverage bias. Another source of bias is non-response bias. Suppose we emailed 100 teenagers, but 30 of them did not respond to the survey. Are the 70 people who did respond to the survey truly representative of all the teenagers in New York City? You might want to ask yourself, why is it that those 30 people did not respond, and aren't their opinions as equally valuable as the people who were interested in responding to this survey? Another form of bias is actually response bias. This is when the participants in your survey consistently provide inaccurate information to answer your questions. And the last source of bias is the wording of questions. If questions in a survey are worded in a way that is confusing, or if they're not neutral so that participants are likely to give certain responses, they can also lead to bias in your survey results. Now let's take some time to do a couple of examples to put what you've just learned into practice. The following problem is on page 229 of your textbook. Call the shots. An advertisement for an upcoming TV show asks, should penguin control be tougher? You call the shots in a special call-in poll tonight. If yes, call 1-900-720-6181. If no, call 1-900-720-6182. Charges 50 cents for the first minute. Over 90% of people who called in said yes. Explain why this opinion poll is almost certainly biased. You can pause the video now to think through your response to this question. Of the sources of bias that we've talked through, this opinion poll is subject to two sources of bias. The first one is voluntary response bias, because everyone has a choice to opt into this survey. So only those people who feel most passionately about this subject are actually going to take the time to call in. Lastly, this survey is also subject to wording bias, because of the part that says you call the shots in a special call-in poll tonight. They are suggesting a certain sort of lack of neutrality to the people listening to the survey. We're going to look at one more question that you will complete at home and bring into class the following day. This example is on the following page on 230. It's a sampling at the mall. You have probably seen the mall interviewer approaching people passing by with a clipboard in hand. Explain why even a large sample of mall shoppers would not provide a trustworthy estimate of the current unemployment rate. So take time to write a thorough response to this question and bring your response to class tomorrow. So we've just spent some time looking at the pitfalls in sampling. Tomorrow we're going to look at how to sample well and one key principle that can take you a long way in making sure that your sampling methods will produce accurate results.